Hello and welcome to our Ranorex webinar, Mastering RanoreXPath. My name is Andreas and it's a pleasure to be your host today. Let's start with a short introduction and a few facts. The target audience for today's webinar is supposed to be at practitioner's level, which means users with a basic knowledge and at least a little experience of working with Ranorex Studio. There's no need for any preparation. The test examples are available for download in the user guide. And be aware that this webinar is being recorded. It will be available for you offline afterwards. And today's webinar duration will be approximately 1 hour. We have an extensive and interesting program for today. And I would like to start by showing you what I will show you for today. First of all, I would like to talk to you a little bit about UI elements, their roles and capabilities, which is somehow a little bit of theory ahead, but it gives us a common understanding and it gives you an overview of how Ranorex treats UI elements and how the Ranorex path is being created and what his characteristics may be. We will then talk about the blueprint of the Ranorex path, so how is it created, or what components does it consist of. We will see of how to construct the Ranorex path, and we will dive deeper a little bit into its characteristics. Afterwards, I will show you a very nice feature within Ranorex Studio, which is tremendously underestimated. It's the so-called build path options, where you can control the depth of a Ranorex path in its practice. And finally, we will have a look at handling of dynamic identifiers once you are confronted with those. Additional topics along the way will be, of course, lots of Ranorex path examples. I will show you how to narrow or generalize the Ranorex path specification. And we will have a look at tree and table element specifications. And finally, we will deal with the so-called RanoreXPath weight rules application, which is, it's linked to the handling of dynamic identifiers. So this is our program for today. And I would say, let's start into it. And I would like to, show you a little bit of theory. It's only a couple of minutes, but I guess it's worth the time, because then you know what we are talking about. And when it comes, so let me first take a spotlight here. So when it comes to a UI element on the screen, so for example, we have a radio button here with the gender selection of female or male gender, then this is the UI element within the application under test. And every UI element in the application under test has its so-called inner representation within Ranorex Studio. And the inner representation can be seen within the repository. And every UI element there consists of a so-called logical name, and it consists of a so-called Ranorex path specification. So Ranorex identifies the type of the UI element on a best guess method and maps it to a set of specific rows. This is something which I would like to show you right in a second. So Ranorex builds a kind of a tree-like structure. So you can see it here on the screen. Once we would like to identify this text element, this single text input line there's a tree-like structure which is derived from the element. And I would like to directly show you this within RanoreXSpy. RanoreXSpy is our tool of choice for today's webinar. RanoreXSpy is responsible for identifying UI elements and tracking them and creating a Ranorex path out of them. So once I hit the track button here, and let's say I identify this text entry field here, you can see that by the red bar. Oh, I should make my what you see here is the complete tree of all the applications on my desktop. So what I do now is I set my application under test as a root element, and now I'm tracking this UI text line again. So what you see here is a nested tree of elements. So, but I should have, yeah. Yes, I got it here. So I have it now. So what you see here is a nested structure of elements, and this nested structure is from outside to inside. So first of all, if we go to the browser there, then you can see it here. This is my top level application. You can see it in the screenshot on the right side here. And one level down below there, we have this panel, this selection panel with all the registers in here. One level down below, we have the single panel of our introduction, and then we have the text line for the input text fields, and finally we have the text field itself. So it's a nested kind of structure where Ranorex builds a kind of a tree, a nested tree, and all the UI elements within one application on the test are sorted into this tree. But how does Ranorex does this? And this is our last theory slide. How does Ranorex does this? Ranorex does this by, a rather sophisticated approach, and I would like to simplify it, explain this to you. So imagine we have a radio button here. So it's the female radio button here. And then we have, first of all, Ranorex tries to map a so-called technology independent role. If no role is found, then there's an unknown role. But now let's imagine here Ranorex identifies this UI element as a radio button. So this is a technology independent role. And then we distinguish between so-called role-specific characteristics and technology-specific capabilities. Let's follow this path up here. So the role-specific characteristics are derived directly from the UI element. There's some general characteristics, layout characteristics, dynamic characteristics, role attributes, and so on and so forth. So there are some kind of categories. And finally, we end up in so-called attribute value pairs, where, for instance, you can see that the enabled attribute is true, the visible attribute is false, the control text attribute contains the name female, and so on and so forth. And on the other hand, we have some technology-specific capabilities, which mean they classify, or they try to derive the technological background of the UI element when it comes to, let's say, WinForms element, a mobile plugin, an Office plugin, and so on. So we have some 15 plus categories and more than 167 capabilities, and they also end up in attribute value pairs. And what I would like to tell you now is that at the end, you have access to all of those attribute value pairs when it comes to identify and track a UI element. This is rather a complex technology behind, and what I would like to show you today is how easy it is once you recognize the basic concept to create a stable and well surviving RanoreXPath specifications through the modification process of your application under test. So enough with theory, I guess, and let's step into the so-called blueprint and RanoreXPath characteristics. So I would like to further on now explain to you how a RanoreXPath is created. And the first thing I would like to show you is the so-called concept of a RanoreXPath architecture. So first of all, every RanoreXPath element, so every element of a RanoreXPath consists of a so-called axis. This is usually the slash. And then we have a node, which is usually the role, let's say the button here now. And then we have optional predicates, which further specify this button. So if you want to specify this button, you in the first attempt, let's say it has a control name, and the control name is RX button exit. And to show you how this is done in practice is simply, let's track now. Let's track now. Oops. sometimes SPY comes out of, yeah, sometimes SPY hangs up. If I use SPY not exclusively, but within, I changed now between the PowerPoint presentation and SPY, and this is why sometimes I need to restart it or refresh it, and I do it now for further use here. So I use the track button to track the exit button here. And what you can see here now is, yeah, the anatomy of my RanoreXPath. About the form element here. Let's focus on the button element here. So here you can see I have my role, which is the button, and usually I have the control name, which is called RX button. And down there I have a so-called screenshot where you can see which element has been tracked now. And I could do that with every single other. So let's focus on the submit button again. You have a button element on the right side here. So it's the button, it's the control name, button, submit username. And you could do that with every single UI element in your application. And when it comes to a complete RanoreXPath construction, you don't have one element, you have many elements, and the elements always start with a so-called root element at the beginning and the node element at the end. And in between, you always have consecutive elements defining the path from the root to the node. So this is something which is very easy to demonstrate. So I there had my submit button here. I clicked on the submit button, and the RanoreXPath specification up here contains, first of all, the root element, which specifies my application under test. So it's the RX mainframe, whereas the node element is the button itself. And in between, we have two different RanoreXPath elements specifying first the tab page list and then the tab page itself. So this reflects this onion-like or tree-like structure. So if I step into the path editor, then you can see this tree-like structure here from the application under test down to the tab page list, the tab page itself, and finally the button. So, and this is also been reflected here. So we have the application under test, which you can see on the right side here, then the tab page list, the tab page itself, and finally the button in there. So this is how a RanoreXPath is constructed out of the architecture of the graphical user interface from my application under test. And what Ranorex does is Ranorex does this by a special type of strategy. So Ranorex usually always tries to be as detailed as necessary, but to be as flexible as possible. So Ranorex has some kind of tracking strategy, and the tracking strategy always deals with the robustness and the execution speed. For example, if a RanoreXPath is very detailed, then it's not very robust against changes in the graphical user interface, but it has a very high execution speed because Ranorex identifies each element, each UI element very uniquely. And on the other hand, if the RanoreXPath is very flexible, then it becomes very robust against changes in the graphical user interface. So Ranorex is able to identify UI elements even if they change in position within the graphical user interface if the path is flexible. But the execution speed draws down when flexibility raises, because Ranorex always needs to search again and again for the element to find it. And I show you now in the further discussion what does this practically means. So we would like to step into these RanoreXPath options now. This is what I would like to show you now. So first of all, let me step into this object identification panel here. And this is in our Ranorex, we have a demo application, and within the demo application, we have this object identification panel here, and this gives us now a playground to play around identifying these different buttons. And what you can see here is now that I also have inserted here some levels of depth. So within this object identification area here, we have two buttons in the basic level. Then we have two panels here, the panel 1 and the panel 2, which define one further level within this panel here. And there are 4 buttons here, so the button 1 and 2 in the panel 1 and the button 1 and 2 in the panel 2. And we have one more level with 4 more panels. So we have panel 1, 1, 1, 2, 2, 1, and 2, 2, which represent a further level of depth within this object identification area. And yeah, you will see how this is gonna use within the tracking mechanism right in a second. So first of all, let me now track my button here, the button number 1. And let's see what Ranorex does with with this current strategy here. So what I have here is my RanoreXPath up there in my line here. So what I have here is, first of all, I have my demo application. It's the application under test. It's the first element. Then again, we have this tab page list. Then we have the tab page. And finally, we have the button here. And the button is identified by the control name button number 1. And what you can immediately see is that you have a very complete RanoreXPath here. So it's no level is missing, every level is listed, and every level is taken into the RanoreXPath specification. And it took around 520 milliseconds to identify this button here. So this is an information which you have in SPY here on the lower left corner. It took about 519 milliseconds to identify this button. So what I can do now is I would like to show you the so-called depth setting of the Ranorex SPY. So we are opening the settings dialog, and what we have in here is the so-called advanced settings, and here we have the build path options, which are now open. You can see a number of available options to setting here. So it's the sibling cost factor, the attribute cost factor, the capability cost factor. So, but I recommend to forget all of those. What I would like to show you is the so-called quantile threshold. We have hidden it in here, and we decided to put it into a more prominent space within the next Ranorex version, but for the moment we have it here. So it's the quantile threshold, and I preset it to 100%. This is not the default setting, but I wanted to show you how to use this quantile threshold, and this is why I preset it to 100%. And what I do now is I now set it from 100% down to 0. So I set it to 0, and I click OK, and I click OK. And now what I do now is I track my button again. So I track the same button again. Here you can see the red frame, and I click it. And what I have now is I have a completely different RanoreXPath. You can see it up here. The RanoreXPath now only consists of 2 components. So it consists of my application under test as the first component, and it consists of the button itself as a second component. And in between here, the so-called access specifier is a so-called wildcard. And what Ranorex does now with this strategy is creating the most possible flexibility. So Ranorex is telling me now, okay, I'm searching for a button with the control name button 1. And I don't care where this button is located. So I don't care where within the graphical user interface it is, as long as the button is in my application under test. So this is the shortest possible RanoreXPath specification for this button, and it guarantees, the greatest flexibility, because the button now can change from this position in this level to any other register within the graphical user interface. I could hide it within any other position or panel in here. Ranorex would be able to find it as long as it is within the application under test. But on the other hand, I have a very slow execution time. So if I have a look at my search time here, you can see that Ranorex took approximately 2 seconds to identify and find the button. So whenever we perform a test now, having this very short but flexible path, it takes me 2 seconds to identify this single button. And this is due to the fact that Ranorex has to search for every single panel within my graphical user interface to identify the button again. So this is the shortest path, but it has the longest identification time and it's most flexible compared to the complete path before. And now we have the two extreme forms of this RanoreXPath specification. We have a complete one and we have the smallest one. And yeah, as always in life, the truth lays in between. So we have something in between, and there's a recommended setting for that. So again, I open the settings, the advanced settings, and the build path options. And the default setting for this quantile threshold is in between with 50%. Whereas we recommend, you need to try that out on your own, but we recommend a setting between 30 and 50%, and somehow 30 or 40% will be possibly a very good quantile threshold to create stable but fast Ranorex paths. And I click OK. I now show you what Ranorex does by again tracking this button and show you the RanoreXPath specification, which is derived from it. So again, now we have 3 elements here. You can see it. We have the node element, which is still the button here. We have the first element, which is the top level element, is my application under test. And in between, we only have 1 level left here. And again, here we have some wildcards, which I will explain in a couple of seconds. But what, let me first again have a look at the search times. Now we are less than 800 milliseconds. So if you remember, the first searching time was about 500 and something milliseconds. The longest search time was about 2 seconds, and now with the setting of 50% for the quantile threshold, we are less than 800 milliseconds. So we are a little bit slower than the shortest search time, but we have gained some flexibility in our path. And this is what I would like to show you now. So I go into the path editor now, and what you can see now here in the path editor is that Ranorex, obviously, we still have these 5 levels. So we have the application under test, and there would have been 2 other ones. You remember this is the tab page list and the tab page. And down there, there's now the tab page and there's the button. So what Ranorex does is it pins down the button to the parent panel, the parent UI element, which is in our case the tab page. So Ranorex tells us now, I'm searching for a button. It should be, or it must be, within the tab page object here. And the button itself should have the control name button1. This tab page has the control name RX tab object, but I don't care that much where this tab page is within my RanoreXPath, within my application under test. So I'm searching for somewhere in here, and somewhere is specified by these 2 wildcards, and I would like to introduce them to you now to show you what I mean. We distinguish 3 different wildcard operators. 2 of them you have already seen now. Let's start with the 3rd one here. So it's the any descendants wildcard. It's the / here, and it tells us the UI element could be any UI element in any number of tree levels. So we're searching for an element no matter where it is, down from here. So down from the position where this wildcard is located. What we now had is this / with the wildcard with a question mark, and it tells us it's the any optional wildcard. It tells us we're searching for any UI element exactly here at this position or one tree level down there. So we're searching at the current position or one position down from here, down from where this wildcard is located. And then we have a third one, which is somewhere in between. So it's the any wildcard operator. So we're searching for a new element exactly, not here at this position, but exactly one tree level down there. So this is what these three wildcards specify, and I would like to show you in practice what this means. So let me first of all step back here, and what we do now is we don't search for this control name button for the attribute control name. I put this away, and I'm searching for a text element. So let me search for the text, where the text is button 1. Oh no, let's say it's button 2. So what I'm searching for, and let me tell you this now, is, as I told you right from the beginning, we have access to all of our attributes in here. So you can see that we have access to all the attributes. So I need not take a control attribute. I could use a button attribute, and I have taken now the text attribute here. I could use other attributes too. So every UI element offers a number of attribute value pairs, as I told you at the beginning. And the default one is the control text, because it's usually the strongest one. But now I changed to the button 2 text element attribute, and this means it's the label here printed on the button. So button 2 is this button here, as well as it is, let me show you this with the spotlight. All these button 2s are candidates for tracking and identifying now. And I would like to show you what this means. So I changed the attribute now, and I hit the return button again now. And what I have now is, let me switch back to the result page, and let me see. So what we have here now is I changed it now to the button 2. We still have found the button here, we can see it, and we still have found one button here. And if we would like to have a look, we could use the highlight feature here, and then you can see the button is highlighted here. But what if I now insert the wildcard here, the any descendants wildcard? So again, remember, we are searching now not for a button only here, we are searching for the button anywhere from here down the application, and I hit the return button. And what you can see now is that Ranorex is now obviously finding 7 elements. So we are now inserting here a wildcard, which tells us I want to search for any button with the text button 2 down from here, and Ranorex is finding 7 different buttons. And if you want to see which buttons those are, you can step in on the button itself. So I make this a little bit shorter, smaller here. So as soon as I hover over, you can see it's all the buttons in here, all the button 2s which are identified here. So this is the wildcard any. And now I should also show you the other wildcards in here. So if we replace this any descendants by exactly one level. So we're searching now for a button number 2, exactly one level, as you may remember, one level down from here. So again, I hit the return button and let Ranorex search. And now we have found 2 buttons here. You can see it, 2 buttons are found. It took us approximately 1 second. And if I hover my mouse over the button, you can see it's those button 2s, one level down of the object identification test area. I could extend this to exactly 2 levels. So I could insert another asterisk and hit the return button. And then we will find, did you guess, 4 buttons. It's the 4 button 2s in the lower levels, panel 1.1, 1.2, 2.1, and 2.2. Here you can see that. So, and finally, a little more flexible button is the one with the question mark. So if I insert the wildcard with the question mark in here and hit the return button, then you can remember Ranorex is now searching for a button with the label button 2 exactly here at this level or one level down. So we are finding 3 different buttons here. So it's the basic button at the position and the 2 buttons 1 level down. So this is how these wildcard operators work. So let me see what we have done so far. Yes, I showed you a little bit of theory according to UI elements, roles, and capabilities. We had a look at how a RanoreXPath is being constructed, what components it has, and what the characteristics are. And I also already showed you the RanoreXPath build path options, configuring the threshold, and yes, I showed you how to narrow and generalize RanoreXPath specification. Now let's have a look at some tree and table element specifications. So this is what I would like to show you now. Again, we use our demo application and we have some UI element testing area here. So you can see here's a testing area. You can switch on red lights or green lights. You could reset them. We have a table here and we have a tree here. And this is for exactly the purpose we do now. We are testing how to track table tree items or tree items. So what I do now is I would like to show you how to identify a tree item. So let's hit the track button and let's say, let's identify this tree element here. It's called Ranorex Studio Expert. So I track it. And what you can see now is that Ranorex is again identifying this UI element within the complete architecture. So what we have here is at the top level, we have here the demo application, then we have the tab page list, then the panel within the tab page list, then we have the tree view item and the tree itself. So you can see the difference between those two. The tree view item is the upper item and the tree view item is the inner one without the scroll bar and stuff like that. And finally, we have the tree item here. And when it comes to the RanoreXPath and the path editor here, then you could see that Ranorex is already by default using some wildcards in here. So what it does is it tells us we are searching for a tree item. You can see it down there here. And the tree item is identified by its accessible name attribute. And the accessible name is Ranorex Studio Expert. So this is what it's outlined here. So it's identified by its label. And when we go along from the node up to the root, we can see that first of all, Ranorex is using some wildcard identifiers. So any optional wildcard here telling me the tree item should be within the tree here. Of course, the tree is a fixed component of the RanoreXPath specification, also the tab page. So it's searching for a tree within the tab page, and the item within the tree could be in within 3 levels. So within the first, the second, or the third level of the tree. So Ranorex is already inserting some kind of flexibility to even identify this tree element if it changes its position with respect to a level. So it's searching in the current level, 1 or 2 levels down below. And it's also, Ranorex is also adding some flexibility when it comes to the tab page here. So Ranorex says the tab page must be, of course, within the application under test, but it could be in the base, in the root, or in the root level, or 1 or 2 levels down below. So we could change this tab page here within here, and Ranorex would even be possible to find the element. So this is how Ranorex identifies a tree item. And even if I now track one item down below, so I'm not identifying this tree element, but a subtree element here. Let's say the regular expressions in RanoreXPath. And then what you can see first is that Ranorex does not distinguish between a tree element or a subtree element. It's all tree elements. So all the elements in here are tree elements, and they are uniquely identified by their accessible name and the position in between. And again, I'm searching now for, yes, a tree item which can be anywhere. You can see the wildcard here within the tree, and the tree must be within the tab page, and the tab page must reside in the root level or 1 or 2 levels down below the application under test. So this is what Ranorex does. And yeah, I also should introduce you now to some, access specifiers, because sometimes it's not necessary to only identify one element here, one tree element here, but sometimes you would like to specify elements based on the identification of one element. So for example, if you would like to identify all the following sibling elements of this subtree element, it would be user code library, code modules, and Ranorex Studio IDE. So this could easily be done by formulating an access specifier in here. So let me point out how this is done. And this is done by simply adding an access specifier, and it's in this case following sibling. And what are we searching for? A tree item sibling. So once I do this, I'm now finding, let's see it here, I'm finding here the 3 sibling elements of this tree item elements Ranorex Studio Expert. So it's from the Ranorex regular expressions, from the Ranorex Studio Expert down there. It's user code library, code modules, and Ranorex Studio IDE. And these identifiers are introduced in our user guide, and I would like to point that out to you. So let's step into Ranorex homepage, and let's step to the support and the help center. And once there, you should go to the Ranorex Studio user guide, which is the landing page. And down there, we have the Ranorex Studio advanced chapter. And within this section here, we have the RanoreXPath chapter. And down there, we have RanoreXPath syntax. And within this chapter, you find all of these access attributes and functions in here. And for example, you find all this. Let me go down there. This the preceding here. For example, you have what I showed you, the following sibling access specifier. There's a preceding siblings access specifier, and there are a lot more which are all completely described in here with examples. So you can find your way through all the possible functions and actions in here, searching our Ranorex Path user guide chapter. I will point to that out at the end of our webinar too. But now let me go one step further and show you how to identify items within the table. So once it comes to a table here, you possibly would like to identify a table cell within, let's say an Excel table or something like that. So let's track again, and let's track this Thomas Bach here, the name of Thomas Bach. And what you can see at first sight is that Ranorex now is not using the name here or the content of the cell. Ranorex is using an attribute which is called accessible name, and this is a combination of a location specification. So it locates it by a row of the column with the first name here. So the column first name and row number 3. So it's 1, 2, 0, 1, 2, 3. So it's starting to count by 0 with John, then Mary, Henry, and Thomas. So it's the third or the fourth one with the index number 3. and Ranorex is identifying the cell in this way. But the problem here might be that it's not robust, that this identification is not robust against shuffling or changing content. So I can hit the shuffle button here, and what you see is that it shuffles all the cells now in a random order, and now the Thomas Bach is now here in the second one with the index 1. And if I step up here and do a refresh, I still identify the element. So you can see it here, one element found, but now it highlighted as Mary because Mary is now in the position where Thomas was before. So this is not very stable at the moment, and this is now where I would like to show you how to make a table item specification being robust against changes. So what I first do now is I first change here. I delete this attribute because it's not a proper attribute, and I exchange it by searching for the content of the cell. So I'm searching for a cell with the content or the text attribute, as we say it, called Thomas. So this is what we're searching for, and now I'm hitting the return button, and what you can see is that unfortunately now 2 elements have been found. So we are finding, of course, the Thomas Bach, but we are also finding a second cell. And if we step over there, you can see it. It's the cell where Thomas is the last name. Here we have Thomas as a first name, and here we have Thomas as a last name. So yeah, we need to do some improvements here. And this is where I'll show you now how to extend the this predicate. As I told you, a RanoreXPath component consists of a predicate with an attribute value pair. And it can be no predicate at all, but it also can be 2 or more predicates. And I can combine them with logical operators and or and stuff like that. So I'm typing in and I'm searching for, let's narrow it by the accessible name again, and I would like to be at the column first name. So I'm searching now. I would like to take the spotlight to show you. I'm searching now for a cell with the context with the content Thomas, but only in the column of first names. I'm not searching the last names column here, but only the first names column. So let me try that out and hit the return button. And what we have now is, yes, we are finding, we didn't find any element. Maybe this is due to some problem in here. So I'm searching for the first name, but I'm not quite sure if first name is the only. So let me change this and let me not make an exact match, but let me make it, the accessible name begins with first or first name, so it doesn't matter at all. And now we should be able to find a cell. Yes, we have it now. So sometimes the label in here is not completely the same or similar to the accessible name. So it's better to not make an exact match, but to start with match. So it must start with the first for first name. So now we have the name Thomas, and this is robust against shuffling. So if I shuffle this now, for instance, now it's Thomas Bach down there, and I do a refresh here, then I still have my Thomas from Thomas Bach. You can see it. So I can shuffle that as many times as I want to. It's still, this RanoreXPath specification still finds my Thomas Bach. And by the way, if you're not searching for this specific cell, but a cell within the line here, so let's say you would like to know the age of Thomas Bach, then it would be the cell number 1, 2, 3, 4, the cell number 4 from here. So this could be done by some relative position, which is also pointed out in the user guide. So I'm stepping one step back, and then I'm searching for the cell number 4 within this line, within this row. And now we said, as you can see, it's the age 42, which has been searched. And now I'm shuffling again. Now we have Thomas Bach in the last position. So again, you can see it's finding the age of Thomas Bach. So this is working here, and this is tracking and identifying table elements within, yes, an Excel table or something else. So let me see what we have done so far. Yes, I showed you how to identify tree and table elements, and what is left to do is to show you how to tackle dynamic identifiers once you are confronted with those. The ones of you who have been doing some web testing will already know that websites often provide dynamic identifiers, UI elements based on dynamic identifiers. And Ranorex, with its version 9.0, introduced some improved algorithm. You can find it in the settings within the plugins. There we have some, here we have it. We have some web plugin, and there's the dynamic ID identification algorithm. So this is turned on by default. So usually if you do some web testing, usually you should not find any dynamic identifiers within UI elements in web pages anymore, but still the problem is still there that you reach out for some dynamic identifiers, and I would like to show you how to tackle this problem. So the first thing is I would like to show you how to do that. So we have some panel here to play with dynamic identifiers here, and every time I make this image visible, we have a dynamic identifier here. So the current identifier of this picture, of this image, is changing on a random basis. So I turn it off and turn it on again, and you can see as often as I do this, the identifier always changes. And now let's see what happens if I track this this image here. So I track this image, and what you can see here now is that Ranorex Studio is identifying this picture by means of an attribute which is called control name, and unfortunately this is our dynamic identifier. So you can see it here, it's the control name attribute, it's a dynamic identifier. What is the consequence out of that? So if I change this 2 times, we have a different identifier. We go over here, and you can see now what happens is, as soon as there is a refresh, you can see that Ranorex is not able to identify the image anymore because the identifier has been changed. So it's a new identifier now. So this is the problem when it comes to dynamic identifiers, and the basic principle behind is a very easy concept. So Ranorex identifies different attributes, as I already told you. And what Ranorex does now is that every single attribute has a so-called weight factor. The weight factor itself is an integer number between 0 and 200. Weights less than 100 are ignored for the Ranorex specification. And Ranorex has a simple strategy. Ranorex always takes the weight with, always takes the attribute with the highest weight. This is why we have 4 attributes here, and these 4 attributes have different weights, and Ranorex is choosing the control names attribute because usually this attribute turns out to be the stablest one, so the best one, based on our experience. But sometimes shit happens and the control name attribute isn't the best one, and this is where we need to find or modify the strategy. And now I show you how to do that. So the access point is very easy because it's within here, within the browser. We have here the option to edit the path weights, and we open this up here now, and what you can see here now is that we now have opened the so-called rule Ranorex editor, Ranorex path weight rules editor, and what I do now is I define a new rule where I set this weight. So I add a new rule, and where's my I add a new rule. Here we have it. And now we give it a name. So we call it RX Demo App Dynamic ID rule. And what we do now is we're changing the control capability. So it's within the controls capability. Where do we have it? So sometimes it needs to be a little bit invested, a little bit search time to find the correct attribute. And here we have these 4 attributes within the control. And what we take is we take the control names attribute, which has a current weight of 150. And what we do now is we lower this to 99. So what we do is we lower it to below 100. And this means that this control name attribute will never be used for a RanoreXPath specification anymore. A better attribute will be chosen. So I apply this and I say, okay. And what I do now is I again track my image here. So I track the image. And what happened now is that we now have a RanoreXPath specification which does not contain this dynamic identifier anymore. So you can see I only have a new, it's the control type name attribute, which has a weight of 105, and it was chosen instead of the control name, control text, control name attribute. You can see it here. So once I go back into the, no, here we are. Here you can see the control name attribute is grayed out, so it won't be taken anymore. It has a weight of 99. The control text attribute has a lower weight than the control type name one, and this is why we choose this one. Again, I would like to show you something in advance now. The problem now is that if you have another image, so for instance, I'm in the image-based automation register here, and there is the same image in here, so I can make it visible here. If I track this image here too, what happens? Ranorex Spy is perfectly obeying my rule. So let me now. Oh, I should do something different. I should put this off and this on, and now we track it, and now we should see that it's, oh yes, it's using the control type's name here again, but this is nothing which should be done. So usually it's better to define a rule. So let me go in here again. So here, the control type name is always used for every picture now. And this is usually why it's better to add a condition to this rule and define the pattern which follows the creation of this identifier here. So this is something which you could do by adding a condition here too. So let me see what we have done so far. I guess we are almost done. And this is why I come to the end and would like to talk a little bit about what's going on now. So first of all, the resources of this can be easily found in our user guide. As I already showed you, and we'll do it again here, is we have the RanoreXPath chapter here, which starts with a short introduction. You can watch the on-demand webinar even here too. It gives you some information about some recommended knowledge, so it's not for basic users. Then it's the RanoreXPath basics here, and where all of this information I gave you at the beginning is explained in here too. It comes across the syntax, and of course we have a lot of examples here. So almost all the examples which I showed you during the webinar are listed in here. So you can really have a look here. You can test it on your own and try them out in a step-by-step way. So this is a very good resource of learning how to tackle RanoreXPath. And there's an expert section in here too, where we have this mapping of dynamic identity UI elements. There we explain the principle, the concept of the RanoreXPath weight rules and how to change them. So this can be found within the user guide. So What is to be expected next? You will receive a follow-up email by today, and this email will include the video download link. And if you did not happen to ask all the questions during the webinar, please reach out at webinar@ranorex.com and we will answer every single question which is asked there. My name is Andreas Auserhofer. I thank you very much for spending some time with me, for your attention. I hope to see you soon in one of our upcoming webinars. I wish you a great day. Thank you very much, and yeah, goodbye.